In this recording, we're going to learn about something called logarithms. I'm going to introduce that with a question like the following. How can we solve the equation 4 to the x power equals 10? Of course, you know how to solve an equation that looks like this. 3 to the x power equals 27, right? You just think about how to rewrite these both with a common base. Well, we could do 3 to the x equals 3 cubed. That's what 27 is, and therefore x equals 3. But I can't think of a common base for 10 and 4. So I guess I could approximate. I know my powers of 4. 4 to the 1 is 4. Write that down. 4 to the 1, first power is 4. 4 squared is 16. So to get a 10 out of a power of 4, it's got to be somewhere in between a 1 and a 2. Can we agree on that? It's got to be somewhere in 1 and 2. And you could mess around with numbers, and maybe you've already done so. You've messed around with some numbers on your calculator. Why don't you take a moment right now, if you have a calculator that can do exponents, see how close you can get to 10. Maybe 2 decimal places. Play the recording when you've got something. Okay, so hopefully you took time to mess around. Try to find a number for x that when I raise 4 to that exponent, comes out really close to 10. Okay? So we know it's somewhere between 1 and 2. 1 point something. Maybe you'd say, well, it's closer to 2 than it is to 1 because 10's a little closer to, well, I guess it's 6 and 6. It's right in the middle. So we'll see how close it is. Turns out it's pretty close if you go 4.166. You can get darn close, and maybe you got even closer. But this is kind of tedious, right? We can waste all afternoon trying to get close to 10 when there's a button on your calculator that will find it for you in one step. And that button is called a logarithm. We need this thing called logarithms. All right? So if it's not one like this in the top right corner where we can find a common base, we can solve for an unknown exponent using logarithms. Why don't you grab your companion sheet, Intro to Logarithms, and let's get started. First off, it's how we pronounce a logarithmic equation. This is a language here, and there's new notation and new pronunciation. I want you to be able to speak the language of logarithms. So the way we read this notation is log base b of x equals y. Okay, we'll say it one more time. It's written out here. Log base b of x equals y. The small number next to the word log that's written down in small is the base. Now, rather than tell you what a logarithm is, I'm going to have you discover it using your calculator. So, you've got log base 25, log base 5 of 25 equals what? Well, let's go to our calculator and figure this out. So it turns out there's a button over on the left side that you may have noticed says log. When you press that, log. But you don't have any place to write the log base. On question 7 and question 8, that would be one where you would use that button, log, without a base specified. But the one in number 1 says log base 5. So we need a different tool. Hopefully you have a graphing calculator like this accessible to you that can do log base. So you're going to hit alpha, window, and the fifth choice is log base. Now I've got space to put in my 25 and the 5. Came out 2. So, turns out log base 5 of 25 equals 2. Get comfortable pronouncing that. We'll say it one more time. Log base 5 of 25 equals 2. Okay, I think I've shown you enough. Why don't you pause the recording, fill out each one of these using your calculator, using the log base button, and then play the recording when you're ready. Okay, so hopefully you took time to get an answer for each one of these. And here they are. Okay, so log base 7 of 49 is 2. Log base 5 of 125 is 3. Log base 7 of 7 is 1. Log with no base written of 10,000 is 4. And log with no base written of 100 is 2. So I'd be interested in what your ideas are about this log with no base. And then we get into some unusual ones over here. These both came out to be zeros, and maybe you have an inkling about why. Log base 4 of the fraction 1/64 came out negative 3, and log base 2 of the fraction half came out negative 1. And finally, these are kind of switched around from example 2, number 14 and number 2. Log base 49 of 7 equals the fraction half. So, what's a logarithm? Well, if you notice here, I might be able to write an exponential equation using these pieces. And I'd like you to do that over here. How can I put together the pieces 5, 25, and 2 to make an exponential equation? Of course, that would be 5 squared equals 25. Okay. Can you write that in the in-between space? Can you make an exponential equation out of each one of these? So it'd be like 7 squared equals 49. Okay. If you could do that for each one of these, and then think about what it is that the log is equal to, we'll have our answer. Go ahead and play the recording when you've done so. All right, so hopefully you came to the conclusion that in each one of these cases, the log in a single word is the exponent, okay? In a single word, what is a log? It's an exponent. You might say, well, that's 2 words, and you'd just be being a smart, you know what, about that. It's an exponent, okay? Smart aleck, we'll say, okay? So a log is an exponent, and it's very handy to be able to find unknown exponents like this x that we were trying to find. I bet you already have an idea about how we could find that unknown exponent on your calculator. No fair jumping ahead. All right, given that we know a log is an exponent, let's see if we can figure out each one of these unknown boxes. Okay? And if you're stuck, what I'd like you to do, if you look at this and you say, I don't know how to do it, think about how I could write it in an exponential form. Okay? In other words, we say log base 2 of we don't know, I guess I could call it an x, equals 5. What would you think would be the number that would go here? And if you think you've got something, you can of course check it with your calculator. Log base 2 of some number is going to come out 5. Okay. Play the recording when you've had a chance to get as far as you can. Okay, so hopefully you had an opportunity to figure out each one of these and check them with your calculator. So like for the first one, I'm trying to figure out some number that I can raise 2 to the 5th. So this would be log base 2 of some number equals 5. So that's like 2 to the 5th is going to come out with that number. All right, and that number is 32. Right, and so on. Why don't you, if that was very helpful for you, and I'll do 2 others ones, and then maybe you can get a little further. So maybe one like this. You say, I don't really know what to do if the x is down here, the unknown thing is down in the base. Well, if you're stuck, put it into exponential form. So that would be saying the base is unknown to the exponent equals 2. And think about how you could get rid of this get rid of this unwanted exponent. Get rid of a 3. Get rid of the 1/3 by cubing both sides. All right, and so therefore this is an 8 because it's 2 cubed. All right, so we know what to do if it's the argument is unknown. It's called the argument of the base, and we know what to do if the base is unknown. All right, get as far as you can, then play that recording when you've got it. All right, here are all your answers, and you might have figured out that this number 29 had lots of possible answers. It can be any number as the base that's a positive real number except for 1. So like 7 to the 0 is 1. 15 to the 0 is 1. All right, and I've shown in a few cases here how to get, like for example, this one, number 27, if you weren't sure what could you raise to the fourth power to get a 16, well, then just raise both sides to the reciprocal exponent. So if we did x to the fourth, raise both sides to the reciprocal exponent 1/4. Use our calculator, we're going to get the 1/2. I know it looks like 1/9. It's a 1/4. I'm going to make it better. Okay. All right. Thanks for watching.